let's simplify this rational expression. And first notice that we have numbers and variables. And I like to split those up because the way that we look at them is different. Here's the square root of 72, and here's the square root of x to the 15th. So let's talk about the number first, the square root of 72. I'm going to look here in my list of squares, and I'm going to say, I'll ask myself, is 72 one of my perfect squares? Right? So I look around here, 72 is not in there. So the next question is, does one of these perfect squares divide into 72? And you can get out your calculator and you can start. You'll find out that 4 goes into 72. 9 also goes into 72. But the best number to use is 36 because 36 does go into 72, right? 36 is 4 times 9. Got that? 36 is 4 times 9. So if you take your calculator, you do 72 divided by 36, you'll find out that it's 36 times 2. So for this square root of 72, I'm going to break it up into the square root of 36 times the square root of 2. And the reason I did that is because I know the square root of 36 is just 6. And I don't know the square root of 2, so that part will be left underneath the radical. So the square root of 36 is 6, and then I have the square root of 2. Now let's look at this one, the square root of x to the 15th. I know that my index here, what's my index? It's the little number in the radical right here. It's actually a 2, okay? If they don't write it, it's a 2. So I'm looking for groups of 2. Now, how many groups of 2 can I take out of 15? And the answer is 7. 7 groups of 2 is 14. But then there's one more left over. So let me write it like this and see if this makes sense. This is the square root of x to the 14th times the square root of x to the 1st. Okay, so you see how that's 15? Now I do know the square root of x to the 14th. Right? How many sets of 2 are in here? And the answer is 7. So the square root of x to the 14th is x to the 7th. And I got to take that out of the radical. And what about this x right here? Well, can't take it out. Still stuck under the radical. All right, now, I've simplified all I can. Let's clean it up and put it together. On the outside of the radical, I'm going to have 6 x to the 7th. And inside the radical, I'm going to put these back together. 2 and x are still stuck under the radical. And that's it. Okay, you could stop here if that makes sense. If you want to see me do this another way, I'm going to do it another way right below. Okay, I'm going to do it the long way. So here's the same radical, the square root of 72 x to the 15th. And let's say I break this down as small as I can. Now I'm going to break the number 72 down into prime numbers. Okay, and if you need to learn about prime factorization, you can go find a video on that. But you can trust me here that 72 is 2 times 2 times 2 times 3 times 3. Okay, if you put this in your calculator, you're going to find out that that is 72. And now x to the 15th. So I'm going to list out 15 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, hand cramp. Ow. All right. So I broke this down as small as I can. Now you know that because this is an index of 2, it takes 2 of the same thing underneath to bring one of them outside. So let's group them together. Let's see what we can take out. I can take out a 2 on the outside. I can take out a 3 on the outside. I can take out an x on the outside, another x on the outside, another x, another x, and another x on the outside. Okay, so let me put my radical back. I'm going to move it over to the right a little bit because I know I need some space over here on the left. Now, what can I take out of this radical? Well, I can take out a 2. I could take out a 3. And then I can take out a bunch of x's, right? Let's see how many. 1, 2, 3, 4, 5, 6, 7. 7 x's. 1, 2, 3, 4, 5, 6, 7. Okay. Let me do that better. I'll put it here. I'll make a little bit of space. 7. All right. Now, what would be left over inside the radical? Well, a 2 and an x. Okay, and now you can see what we took out. Look on the outside. Let's put this back together. 2 times 3 is 6. How many x's do we have? 1, 2, 3, 4, 5, 6, 7. 7 x's is going to give me x to the 7th. And then left over underneath the radical is 2x. Okay, so that's a way to show it where you break it down into as small of pieces as you possibly can. All right, you can see that these two are the same. But you're going to want to try to do it this quicker way and identify what you can take out without having to break it down and having to write it all out like that. But if you need to write it out, when in doubt, write it out.